this particular L1 inductor and I'll switch it to the L2. So let us see what happens. You can observe the waveform here. It is again sinusoidal waveform we are getting here, and the frequency here we are getting 286 kilohertz. Previous frequency was 291. So here we are getting 285 kilohertz, and peak to peak voltage is 114 millivolt. Peak to peak voltage is 114 millivolt. Okay, I have noted it. अरे reply करो fast.
Yes, sir.
Yeah. Now what I'll do, I'll use another branch to select this particular capacitors. So I'll use the second branch here, this one. Okay. So here this capacitor branch I have changed and I have chosen this particular. Okay, this branch I have chosen. So let us see what the output we are getting of this particular combination. So here you can observe the frequency has dropped down to 240 kilohertz, and again the peak to peak voltage also has dropped to 92 millivolts here. 92 millivolts. You can see here. So please take a note of this. Okay. Now I'll change this inductor and I'll choose L1 inductor for this combination. Let us see what happens. Yeah, for this combination I am getting 333 kilohertz frequency, 333 kilohertz frequency, and I am getting 200 millivolt peak to peak voltage. The waveform is sinusoidal for any combination, but you will be getting different frequencies and different voltages for different combination of L and C. Okay. So this is what the Colpitts oscillator. Okay. I'll show you this particular circuit that is connecting these all wires. Okay. So this is what the circuit. As I told you, this is the tank circuit. This is the tank circuit, and this is the transistor amplifier circuit. So at the feedback, at this particular end, we are giving the feedback from this tank circuit. So this transistor gives phase shift of 180 degree, and this feedback circuit, which is called as a tank circuit, LC tank circuit. This LC tank circuit gives the feedback of 180 degree. Okay. So the total phase shift from tank circuit we are getting 180 degree, and from transistor we are getting 180 degree. So overall phase shift we are getting 360 degree. So that is what the condition for oscillator. Got it? If you are having any difficulty or any doubts, you can ask. Yes, is it understood? Shall I go? Shall I go to the next one?
Yes, sir.
So here this is the stable multivibrator. So there are two transistors, T1 and T2 transistor. T2 transistor is fed from this particular circuit. T1 transistor is fed from this particular circuit, this RC combination. And initially, what we consider, let's suppose T1 is suppose conducting and T2 is off. Initially, we suppose that T1 is conducting and T2 is off. Now, if T1 is conducting, so how the circuit will work? Which capacitor will charge? Yes, anybody? If T1 is conducting and T2 is turned off, in that case, how the circuit will work?
So C2.
C2 will charge. What is the path for C2? If T1 is suppose conducting, so this path is make. Okay, so the current will flow from this particular path. Second path to flow the current is this one, from this end, from this through this capacitor, transistor and ground. Okay. So this RV1, R3, T1, T1 and ground. So by this particular path, the current will flow and capacitor, C1 capacitor will charge with this end as positive. Your right side end will be positive and left side end will be negative. Okay. So this capacitor voltage will get applied across this transistor T2. ये जो C1 कैपेसिटर है, C1 कैपेसिटर का across जो voltage charge हो रहा है, that voltage will get applied across the transistor T2. Okay. Now similarly at the second end, this C2 is getting charged by this particular path. So VCC, R2, C2, base of this transistor T1 and ground. Okay, इस पाथ में क्या हो रहा है? आपका जो C2 जो है वो चार्ज हो रहा है, क्योंकि ट्रांजिस्टर T1 कंडक्टिंग है, C2 नॉन कंडक्टिंग है, तो यहाँ से कोई पाथ उसको नहीं मिलेगा ग्राउंड. So that's why it will get charged from this particular path.